Hello students. So in this video, we're going to start with a new concept of trigonometry chapter, that is complementary angles. In the previous video, we have learned about standard angles. In this video, let's learn about third concept, that is complementary angles. Now, you know what are complementary angles, right? Two angles are said to be complementary to each other if you add them. If their sum is 90 degree, that is, if you add them and you get the answer as 90, those two angles are said to be complementary to each other, isn't it? So let's take a triangle, a right angled triangle. Okay. Let me draw the right angle triangle itself. Let's take a right angle triangle. So let's take this right angle triangle A, B, C. Let's take this angle as theta. Okay. Now, if this is theta, okay, this becomes opposite side, and this is adjacent, and this is hypotenuse, isn't it? Now, using the angle sum property of the triangle, can we find what is this angle A? See, this angle B is 90, and this is C is theta. Let's try to find A. Okay. So we know that if you add all the three angles, angle A plus angle B plus angle C is equal to 180. So angle A as it is, B is 90 degree, C is theta, equal to 180 degree. Therefore, angle A is 180 degrees minus 90 minus theta. So 180 minus 90 is 90. So angle A will become 90 minus theta. So that 90 minus theta, let me take it as alpha. Okay. Let me denote this 90 degrees minus theta as alpha. Okay. So what is alpha? 90 degrees minus theta. Okay. So it's very simple. We need not use angle sum property. Directly we can find it. See, angle B is 90 degree. So therefore, if you add A and C, we should get how much? 90 degree, because on the whole, we should get total as how much? 180, right? B is already 90. Therefore, if you add alpha and theta, you should get 90 degree. So alpha plus theta should give you how much? 90 degree. It's very simple, right? Alpha, what is alpha? 90 degrees minus theta, right? So plus theta, minus theta plus theta gets cancelled, 90 equals 90. So as you know, alpha and theta are complementary angles here. Okay. And remember, what is the value of alpha? 90 degrees minus theta. Instead of writing 90 degrees minus theta, I've just taken it as alpha. So alpha and theta are complementary to each other. Remember that, because if you add them, you get 90 degrees. Okay. Now let's find sine alpha, or let's find sine theta. What is sine theta? Sine theta is opposite by hypotenuse, isn't it? So which is the opposite here? AB is the opposite and AC is the hypotenuse. Now what we'll do is, let's find cos alpha. Okay. Now if we are considering alpha as the angle, okay, if we are interested in alpha, then this becomes opposite and this becomes adjacent, isn't it? Because we are talking about alpha now. What is cos? Adjacent by hypotenuse. What is the adjacent? AB is the adjacent, hypotenuse is AC. If you observe, what we have got is sine theta is also AB by AC, and cos alpha is also AB by AC, isn't it? Therefore, sine theta and cos alpha are same. That is sine theta and cos of alpha. What is alpha? Complementary of theta, isn't it? So alpha can be written as 90 minus theta. So what we are getting is a formula which says that sine theta value is actually equal to cos of 90 degrees minus theta. That is, if you take sine of an angle, okay, that will be equal to cos of complementary of this angle. What is complementary of this angle? Theta. It is 90 minus theta. Let me make it very simple. If I take sine 30 degrees, okay, that will be equal to cos of, what is the complementary of 30 degrees? Complementary of 30 degrees is 60 degrees. Or 90 minus 30 is how much? 60. So sine 30 and cos 60 will be same. So this is the concept based on complementary angles. Okay. Again, we have got a very easy technique to remember all this. We have got certain formulas here. We have got an easy technique to remember all these formulas. Let's write down one by one. The first one, second one, and third one. Sine theta can also be written as cos of 90 minus theta. Or let me write it like this. Sine of 90 minus theta. 90 degrees minus theta. That will be equal to cos theta. Cos of 90 degrees minus theta will be equal to sine theta. You can verify it. Tan of 90 degree minus theta. That will be equal to cot theta. The fourth one. Cot of, or let's start with cosecant. Cosecant of 90 degrees minus theta is secant theta, and secant of 90 degree minus theta is cosecant theta, and cot of 90 degree minus theta is tan theta. Now, how to remember this formula? Very simple. See, whenever it is sine of any ratio of 90 degree minus, whenever it is 90 degree minus some angle, you have to put CO if CO is not there, and you have to remove CO if CO is already there. If you observe, what we have got is sine of 90 minus theta. Whenever you got this 90 minus theta, remember, for this, is there a letter CO? No. So you will add it. So it will become COSIN. Cosine. Cosine. Cosine can be written as cos, right? Cos theta. So in the next one, if you observe, it is cos of 90 minus theta. Whenever 90 minus theta is there, if CO is there, we have to remove it. If you remove it, cosine of 90 minus theta. If you remove CO, it becomes sine. So sine theta. If CO is there, remove it. If CO is not there, add it. Even for this, tan of 90 minus theta. CO is not there, so we added CO. It becomes cot theta. So here, cosecant of 90 minus theta. CO is there, so we remove it. If you remove CO, it becomes secant theta. Secant of 90 minus theta. CO is not there, so just add CO to it. So it becomes cosecant theta. Cot of 90 minus theta. CO is there, just take out CO, it becomes tan theta. So this is how you remember the formula, or you can memorize the formula. Let's get into the problems. The first one, we have to evaluate, okay, sine 18 degrees by cos 72 degrees. Remember, when should we use standard angles and when should we use complementary angles? It's a very easy thing, okay. There are only 5 standard angles: 0, 30, 45, 60, and 90. So these are the standard angles. Apart from this, if we get anything, we are going to use the complementary angles concept, okay. So for example, 18 degrees is not a standard angle. 72 degrees is not a standard angle. Therefore, we're going to use complementary angles concept. Okay. Now, what we are going to do here is, the given question is sine 18 degree by cos 72 degree. Okay. Now, remember, we are going to use the complementary angles formula here. Now, use the formula only for the numerator or only for the denominator, not for both. Okay. You're going to keep any one thing as it is and you're going to change the other thing. So let's keep the denominator as it is. Let's change the numerator. As you know, the formula, there is a formula. You can see here. Second formula, sine theta. Sine theta can also be written as what? Cos of 90 minus theta. So the second formula says cos of 90 minus theta is sine theta, or sine theta can also be written as cos of 90 minus theta. So sine 18 degrees can also be written as cos of 90 minus 18. I hope that's clear, because we have a formula which says that cos of 90 minus theta is sine theta. Or I can write it the other way. Sine theta can also be written as cos of 90 minus theta. Okay, I've just written it the other way. Sine theta can also be written as cos of 90 minus theta, divided by the denominator as it is. So 90 minus 18 becomes how much? 72. So cos 72 by cos 72. Both are same. Gets cancelled. The final answer is 1. Same thing applies for the next question. In the next question, tan 26 degrees divided by cot 64 degrees. So keep the denominator as it is, change the numerator. Tan theta. Tan theta can also be written as what? Look at the question here. It is sixth formula. Tan theta can also be written as cot of 90 minus theta. So tan 26 can also be written as cot of 90 minus 26 degrees. So divided by cot 64 degrees. So 90 minus 26 is 64. Cot 64 divided by cot 64. Both gets cancelled. We are left with answer 1. So the value is 1. The same thing applies for the next two problem also. There are two terms here. Earlier it was numerator and denominator. Here it is two terms. So that is, the first term is cos 48. Second term is sin 42. Out of these two terms, we are going to keep any one term as it is and we're going to change the other term. Let's keep the second term as it is. Let's change the first term. Okay. So here we get cos 48 degrees minus sin 42 is the question. Okay. Let's change cos 48. Cos theta can be written as what? Observe the first formula itself. Sin of 90 minus theta is equal to cos theta. Meaning cos theta can be written as what? Sin of 90 minus theta. So cos 48 can be written as sin of 90 minus 48. Okay, theta is 48. That's it. Minus sin 42 degrees. So 90 minus 48 is how much? 42. So sin 42 minus sin 42. Both gets cancelled. Final answer is 0. Same thing applies for the next question. Cosecant of 31 degrees minus secant 59 degree. So cosecant of 31 degrees minus secant 59 degrees. So cosecant theta can also be written as secant of 90 minus theta. So secant of 90 minus 31 degrees minus secant 59 degrees. So 90 minus 31 is 59. So secant 59 minus secant 59. So both gets cancelled. Final answer is 0. Secant 59 minus secant 59 is 0. Okay. So we're going to keep the second term as it is. Change only one term. Okay. Do not change both the terms. If you change both the terms, you will not get the answer. So let's get into the next question. Now in this question, tan 48, tan 23, tan 42, tan 67 is equal to 1. That's what we have to prove. And how many terms are there? If you observe in the LHS, there is only one term because everything is in product. Okay. So if everything is in product, okay. Now how to solve such a problem? In the previous question, there were two terms. So you kept one term as it is and you change the other term. But here there is only one term. So what we are going to do is we are going to arrange first. How we are going to arrange is according to the complementary angles. Okay. Tan 48. Okay. What is the complementary of 48? 42. So arrange. Write that first. Then tan 23. Then comes tan 67. So what we have done is we have made the complementary pairs. So 48 and 42 are complementary. 23 and 67 are complementary. Now what we are going to do here is tan 48. Now out of this complementary pair, keep any one thing, change the other one. Same thing. Out of this pair, keep any one thing, change the other one. Okay. So let me change the tan 48. So tan theta can be written as cot of 90 minus theta. So it becomes cot of 90 minus 48. Tan 42 as it is. No changes. Tan 23, let's change it. It becomes cot of 90 minus theta. Tan 67 as it is. So in that pair, we have kept one thing as it is. We have changed the other thing. Okay. 90 minus 48 becomes 42. Cot 42, tan 42. Cot 67, tan 67. Now remember, cot theta can also be written as 1 by tan theta. Cot theta and tan theta are reciprocals of each other. So cot theta can be written as 1 by tan theta. So 1 by tan 42 into tan 42. Cot 67 can be written as 1 by tan 67, tan 67. So tan 67, tan 67 gets cancelled. Tan 42, tan 42 gets cancelled. We are left with the answer 1. Okay. So remember this. Cot theta can also be written as 1 by tan theta. So therefore, cot 42 can be written as 1 by tan 42. And cot 67 can be written as 1 by tan 67. Okay. So let's get into the next question. Second one. The second one is cos 38, cos 52 minus sin 38, sin 52. Again, the same topic, same concept. There are two terms here. This is one term and this is another term. So keep any one term as it is and change the other term. Let's keep the second term as it is. Let's change the first term. Okay, in first term there are two ratios. Let's change both. Cos 38 can be written as sine of 90 minus theta. 90 minus 38. Cos 52, that can be written as sine of 90 minus 52. So minus the second term as it is. Sine 38 sine 52 degrees. Okay, sine 38 sine 52 degrees. So sine of 90 minus 38. 90 minus 38 is how much? 52. Sine 38. 90 minus 52 is 38. Minus sine 38 sine 52. If you observe, it is like A into B minus B into A. Both are same, right? A into B is same as B into A. Both are same. So this entire thing and this entire thing gets cancelled. So we'll be left with 0. So let's get into the very important question. Third one. What they've given us, tan 2A is equal to cot of A minus 18 degrees. We have to find the value of A. So it is given that tan 2A is equal to cot of A minus 18 degrees. So in the LHS it is tan, in the RHS it is cot. Okay. So what we'll do is make both LHS and RHS as the ratio of same thing. I mean, let's express it in same trigonometric ratio. That is, let's make both the side as cot or let's make both the side as tan. Okay, that's what we are going to do. We are going to make use of the complementary concept. Okay. So we know that tan theta can also be written as cot of 90 minus theta. So that's the concept that we are going to apply here. So tan 2A can also be written as cot of 90 minus 2A. Okay. That is equal to cot of A minus 18. So on comparing the LHS and RHS, cot of some angle is equal to cot of another angle. That is possible only if the angles are equal, isn't it? So on comparing, we get to know that, which implies 90 minus 2A should be equal to A minus 18 degrees. So 90 minus 18 to the other side will become plus 18. A as it is minus 2A to this side will become plus 2A. 90 plus 18 is 108. So A plus 2A is 3A. 3A is equal to 108, which implies, this is degrees. So 3A, 108 degrees is equal to 3A, which implies 3A is equal to 108 degree, or A is equal to 108 degree divided by 3, which implies A is equal to 36 degrees. 3 ones are 3, 3 threes are 9, 1 carry, 3 6 are 80, 36 degrees. That's the value. So here it's a simple logic. If you make both the sides as the same trigonometric ratio, that is both the side as tan or both the side as cot, you can equate the angles. Now tan A is equal to cot B, prove that A plus B is equal to 90 degrees. Same concept again, tan A is equal to cot B. Let's make both the sides the same. So tan A can also be written as cot of 90 minus A. That is tan theta can be written as cot of 90 minus theta equal to cot B. So both the sides are cot, so you can equate the angle. That is 90 minus A is equal to B. Send the minus A to the other side, it will become plus A. So B plus A, or you can tell that A plus B is equal to 90 degrees. Okay. So similarly, let's get into the next problem. If secant A is equal to cosecant of A minus 20 degree, again same logic. We have to apply the same logic here. Secant 4A is equal to cosecant of A minus 20. So secant theta can be written as cosecant of 90 minus theta. That will be equal to cosecant of A minus 20 degrees. So both the sides you have got cosecant, therefore we can equate the angles. Therefore we get 90 minus 4A is equal to A minus 30. So 90 as it is minus 30 to this side will become plus 30 equal to A, minus 4A to this side will become plus 4A. 90 plus 30 is 120 is equal to 5A, or 5A is equal to 120 degrees. Therefore A is equal to 120 by 5. So 5 ones are, 5 twos are, 5 fours are. So therefore A is 24 degrees. That's the value of A. So as you know, it's very simple. You have to make both the sides as same trigonometric ratios. Then you can equate the angles. Once you equate the angles, you will get the answer. Okay. The next question, if A, comma B and C are interior angles of a triangle ABC, if A, comma B and C are interior angles of a triangle ABC, then show that sine of B plus C by 2 is equal to cos of A by 2. Okay. So what they've given is A, comma B and C are interior angles of triangle ABC. So which implies if they are the angles of the triangle, if you add all the three, that is A plus B plus C, if you add all the three angles A plus B plus C, that will be equal to 180 degree. So if you observe the LHS, you need B plus C by 2. You don't need this A. So let's send it the other side. B plus C is equal to 180 minus A. And we need B plus C by 2. So divide by 2 on both the sides. So it will become B plus C by 2 is equal to 180 degree minus A by 2. So which can be written as B plus C by 2 is equal to 180, split the 2. 180 by 2 minus A by 2. So 180 by 2 is 90 minus A by 2. So in the LHS, you need sine of B plus by 2. So taking sine on both sides. Taking sine, S-I-N-E on both sides. So it becomes sine of B plus C by 2 equals sine of 90 degree minus A by 2. And we very well know that sine of B plus C by 2, sine of 90 minus theta, it becomes cos theta. So cos A by 2. Okay. So very simple. A, B, C are the interior angles. So if you add them, you get 180. Observe the question in the LHS, you need B plus C. You don't need A. Send it the other side. Again, it is B plus C by 2. So divide by 2. And you have to take sine on both sides. You will get the answer. Let's get into the next one. Express sine 67 degrees plus cos 75 degree in terms of trigonometric ratios of angles between 0 and 45. That is, the 67 and 75, we have to express between 0 and 45. That is, we have to reduce it to 0 and 45. It's very simple question. So the question is sine 67 plus cos 75. Very easy. Sine 67, sine theta can be written as cos of 90 degrees minus theta, isn't it? Cos theta can be written as sine of 90 degrees minus theta, isn't it? So 90 minus 67 will become 23 degrees. 90 minus 75, 15. So what we have done is the given thing is expressed in terms of trigonometric ratios and the angles are between 0 and 45, isn't it? 23 is between 0 and 45. 15 is also between 0 and 45. So this is the answer, a very, very simple one. So with this, we have completed the exercise problems on complementary angles. All you have to do is remember these 6 formulas. It's very easy to remember. If CO is there, remove CO. If CO is not there, just add CO. Okay. And when we are going to use complementary angles as concept is when there is no standard angles. Okay. In this, out of all this question, the second question, first sub question is a very, very important one. So remember how to solve this. You have to first rearrange, that is arrange according to their complementary pairs. So tan 48 and tan 42 are pair and tan 23 and tan 67 are a pair. In this pair, keep any one thing as it is, change the other thing. I've kept the second thing as it is, change the first thing. Similarly, in this pair, keep the second thing and change the first thing. Okay. So you get cot 42, tan 42, cot 67, tan 67. Make use of the reciprocal relation. Cot can also be written as 1 by tan. So using that, you will get the value of the given question. I hope you guys have understood. In the next concept, we'll start with that is in the next video, we'll be starting with a very, very important concept known as trigonometric identities. Thank you, students.